Good morning, friends. Welcome to Water Resources Engineering class. So, we are dealing with Unit 4, Part 2, Water Requirements of Crops. Precisely, irrigation requirements of crops. So, in today's class, we focus on what is duty, what is delta, what is base period. Is there any relation between duty, delta and base period? And most importantly, what are the factors affecting duty and how can you improve duty? And some important definitions which we come across in irrigation. And finally, problems. So this is how this lecture is being organized, and let us take each one of them. So what is duty of water? Duty means actually with 1 cubic of water, 1 meter cube per second of water, how much area you can irrigate is what we call it as duty. Duty means with 1 cubic of water, cubic means meter cube per second, with 1 cubic, that is 1 meter cube per second of water, how much area you can irrigate, that is what we call it as duty. And what is the unit of that? It is the area of the land per cubic. Hectares per cubic is the unit of duty. And for example, if I say higher the duty means what? Higher the area of the land with 1 cubic of water. So with 1 cubic of water, the more the area you irrigate, the higher the duty. That means what is the meaning behind it? The most economical usage of water. That means with just 1 cubic of water, 1 meter cube per second of water, the area that you are irrigating is increasing, and that means the duty is increasing, means the meaning is economically you are utilizing the water for irrigation. For example, if 4 cubic of water is supplied for a crop in 6,000 hectares, what is the duty? With 4 cubics, 6,000 hectares of area irrigated. With 1 cubic, how much area you are going to irrigate? That is what we call it as duty. So 6,000 divided by 4, 1,500 hectares per cubic. And do you have any approximate values for different crops actually? For example, rice, what is the duty for example? Wheat, what is the duty for example? Sugarcane, what is the duty? Cotton, what is the duty? I have taken 2 food crops, 2 commercial crops. If you take wheat actually, with 1 cubic of water, you can irrigate 1,700 hectares of land. But what is the meaning of it? I can precisely tell you. 1 cubic of water, 1 meter cube per second for a period of, for example, 120 days or 90 days, depending upon the type of the crop. That is what we call it as base period. If you supply 1 cubic of water for so many days, then naturally this much area you can irrigate for the wheat, actually wheat production. Whereas if you see, whereas rice requires more and more water, so that's why the duty is very less in case of rice. Rice only 425 hectares per cubic, because remember it, for rice you require more and more water continuously. The plants, the rice plant will be in water actually. Sugarcane, again you require more water. The more water you require, the lesser the duty. The lesser the water you require, the more the duty actually. Cotton, 1,200 hectares per, that means more the duty means lesser the water requirement actually. So that is how you need to use it. So that's why for wheat and cotton, naturally the duty is higher because the economical usage of water. Whereas for rice and sugarcane, the duty is less. That means more water requirement is there. Then the second definition, what is delta? Delta means depth. What is delta means what? Depth. So it is the depth of water required by a crop during its base period. So during its base period, whatever is the depth of water that has to be supplied for growing the crop, that is what we call it as delta. Then what is base period? Base period means actually from the first watering to the last watering before harvesting. From the first watering to the last watering, but whatever you are supplying the water, that is called as period. Suppose today you are supplying the first watering, after 4 months before harvesting, that is the last thing. So this 4 months period is what we call it as base period. So that is why base period, delta, duty, all these are interrelated actually. So for example, how much depth of water is required for growing a crop like rice? 120 centimeters you require, whereas wheat very less actually, 40 centimeters. The same thing is reflected in duty also, whereas sugarcane also approximately requires 120 centimeters, cotton 50 centimeters. So if you observe it, cotton, wheat, they require less quantity of water, whereas rice and sugarcane, they require large quantity of water. So that is same thing is reflected in duty and delta. But what is base period? Base period means it is the time between the first watering and last watering before harvesting the crop actually. Is there any relation between duty, delta and base period? Excellent question for you. Duty means actually the 1 cubic of water, how much area you can irrigate. What is delta means the total depth of water that is required for growing the crop. What is the base period? From the first watering to the last watering before harvesting, whatever is there, that is entire period is called as base period. So now I want to establish a relation between these three. One is duty, one is delta, and one is base period. What are the units of these three things? Duty is in hectares per cubic, and delta is in meters actually, and B is in days. So this is what the starting point. So first what I have taken, if suppose there is a land of D hectares actually, and how much water I have to supply? Delta meters of water. So area of the land, if this is area of the land, is basically D hectares. And how much water I am supplying actually? Delta water I am supplying actually. So what is the total quantity of water I am supplying? Area multiplied by the depth. So if area multiplied by the depth, delta into D hectare meters. So D into delta, hectare means what actually? 1 hectare is equal to 10 to the power of 4 meters square. So that I put it. So we got it as D into, suppose now this is D into delta into 10 to the power of 4 meter cube, because D is the area, delta is the depth. So D into delta is the volume of water that is required, and this volume is required basically for how many days? B days, because base period is that thing. So if again for this D hectares of land, if you are supplying water actually for the entire crop period, that is what we call it as the base period, B days. In B days, how much you will supply? B into days, days to what you are converting it actually into hours, into minutes, into thing. So how much you are converting? So with 1 cubic of water actually, I am converting into the number of days. 1 cubic is there, 1 meter cube per second, into number of days, B days. B days means B into 24 is hours, into 60 is minutes, into 60 is actually seconds. So total is, so this one is nothing but 1 meter cube per second. With 1 cubic of water, right, we are supplying it for B days. How much is the volume? So this is the volume. So naturally this volume and this volume both should be same. I equated both the things, then I did the correct things, calculations. So then I got finally this is thing. So delta is equal to 8.64 B by D meters. So this is the relation between duty, delta and base period. 1 hectare is equal to 10 to the power of 4 meter square, and 1 cubic day is equal to, it is nothing but 1 cubic day is nothing but 8.64 hectare meters actually. So 1 cubic day, you want 1 cubic per 1 day. So 1 meter cube per second into 1 day. If you do it, this is what you are going to get. So next, after understanding what is duty, what is delta, what is base period, and what is the relation. Duty is 1 cubic of water, how much area you can irrigate. Delta means what is the depth of water required for growing a crop. That is what we call it as delta. And what is base period? From the first watering day to the last watering day before harvesting the crop, whatever period that is there, that time period is what we call it as base period in days. So that we complete. And what is the relation between these three? Delta is equal to 8.64 into B by D meters, where delta is in meters, B is in days, and D is in hectares. Hectares per cubic. So now again the same thing which just now I explained to you what is duty. Now I want to explain to you what are the factors affecting duty. So let us take the factors affecting duty. So number one, methods and systems of irrigation. What type of system you are following? Methods of cultivation, type of crop you are growing, climatic conditions of the crop, method of assessment of the irrigation, and characteristics of the subsoil and soil of the canal from where the water is being obtained, method of applying water to the crops, time and frequency of tilling, and base period of the crop, quality of water, canal condition, character of soil and subsoil in irrigation field. So one after the other, let us discuss. Method and system of irrigation. What do you mean by that? A well-planned canal and proper regulation, the losses due to seepage and evaporation can be minimized. If you are planning a canal systematically, the seepage losses can be minimized with proper regulation, and evaporation losses also can be reduced. Once these losses are reduced, automatically the duty is increased. Efficient irrigation systems, for example, you are going for a lined canal, or you are going for a sprinkler irrigation or drip irrigation, then naturally the duty can be increased. When I say duty can be increased, means with 1 cubic of water you can irrigate more area of land. Then whereas if you take it unlined canals, seepage losses will be more. Similarly, flooding method of irrigation, so much of water is wasted actually. So in these two, there will be enormous wastage of water and loss of water, hence duty will be less. Whereas if you go for these systems, then duty will be very, very high. Coming to method of applying water to crops. So if suppose duty increases if water is applied directly and uniformly basically to the plants. That is a furrow method, basin method. I will explain these methods at the end of this topic. So if you, depending upon the method that you are choosing for applying water, naturally the duty can be increased. If you are not choosing proper method, for example, if you are going for uncontrolled flooding, automatically the duty will be very, very less. Method of cultivation. Suppose if you are having a good practice of let us say removing all the weeding basically and mulching the land, actually covering the land and leveling of the field, all this actually reduces losses, thereby conserve the soil moisture. Naturally in such a case the duty will be very, very high actually. Poor cultivation practices, just like that you are not following properly, you are making the ground actually before sowing the crop, then naturally duty is reduced. Time and frequency of tilling actually. Frequent tilling helps to maintain soil porosity. That means continuously the soil is being what you call it as a plowing the soil actually, making up and down the soil actually, making the soil loose actually at the top surface. Naturally, that indicates the soil absorption capacity or the water absorption capacity of the soil can be increased. Thereby, the water holding capacity of the soil increases, it reduces the evaporation losses. So naturally, the duty is increases. The more times you are making the tilling, more times you are loosening the soil of the what you land, then naturally the soil moisture holding capacity, the water holding capacity in the soil, that increases. So more and more moisture it can hold. Then type of crop actually, for example rice, for example, similarly for example sugarcane, these crops require more and more water, whereas cotton, for example wheat, they require less quantity of water. So naturally, depending upon the type of the crop you are choosing, the duty is more or less. Base period of the crop, the longer the duration, the crop duration, naturally the duty will be lesser actually. For example, the lesser the time base period, the more the duty. More the duty means more area you can irrigate. The lesser the duty means less area you can irrigate. With the same quantity of water you take it, as you have to supply for a longer period, naturally sugarcane requires more and more water for a longer period, leading to lower duty. Whereas if you take wheat or cotton, naturally they require less quantity of water and they are all short duration crops, then that is why they are having higher duty. Suppose climatic conditions, if the climate is hot, dry and windy climates, evapotranspiration is very high, that reduces the duty. Whereas it is a cool and humid climate, naturally it conserves more soil moisture, it increases the duty. For example, you take quality of water in the sense that if it contains salts, the water contains salts naturally. In such a case, you require more and more water for leaching, thereby it reduces the duty actually. Whereas if you are supplying pure and good quality of water, it gives you higher duty. That is the second point. What is the method of assessment of irrigation water? Right? If the discharge measurement method is inaccurate, then naturally people don't use it effectively. So in such a case, duty is less. But if you accurately assess what is the quantity of water that is being supplied, then everybody is cautious. Effectively the water can be utilized, economically the water can be utilized, so better duty actually. And how the canal conditions, for example if it is a lined canal, the losses will be very very less and duty is more. If it is an unlined canal, then naturally losses are more, then naturally duty is lower. Character of soil and subsoil of the canal. Suppose if the canal basically bed and banks are only sandy soils or gravel, then losses will be very very high. Then in such a case duty is very less. If suppose you take the bed and bank soil is what I call it as an impermeable soil or a soil which is a hard soil, then naturally the seepage losses will be very less. Character of soil and subsoil of the irrigation field. One is canal, one is the irrigation field. So naturally, if suppose sandy soils are there, more and more water gets naturally percolate down. So that's why the duty will be very very low, because you require more and more water supplied. Suppose if it is a clayey soil, it retains more and more water, naturally the higher duty. So once again, what are the factors affecting duty? Just methods and system of irrigation. Then second one is methods of applying water to the crops. Third one is what is the type of method you are using for cultivation, and then time and frequency of tilling. Fifth one is what is the type of the crop. That is one angle. Next one is what is the base period of the crop. what are the climatic conditions, what is the quality of water, what is the method of assessment of irrigation water, then canal conditions actually, character of soil and subsoil of the canal, character of soil and subsoil of the field. So these are the 12 conditions on which the duty is going to be affected. Very, very important question. And what are the methods to improve? If you know the factors affecting, automatically methods for improving their duty, you can yourself write it. The 12 points, you can write it as it is in this portion actually. For example, what is the thing? If you assume suitable method of applying water, yes, duty can be improved. Land is properly plowed or then leveled, then you can improve. The land should be cultivated frequently, yes, because barren lands naturally duty will be very, very less. Canals line is there, duty can be improved. Then ideal length of the canal should be reduced, because the more the length of the canal without usage of water, more seepage losses. Then rotation of crops is one of the important things actually for increasing the duty, and such that good quality of water you need to supply. The alignment should be such that the cultivable command area are concentrated along the side of it. When you are aligning the canal itself, wherever the irrigation fields are there, through that naturally your canal should go. Otherwise, if canal going somewhere and irrigation lands are somewhere, then again supplying water becomes difficult. Then farmers must be trained on the proper usage of water actually. Then volumetric method of assessment is the best method for as far as for duty is concerned. So these are the same, the 12 points whichever you have learnt, and the same 12 points if you put it in other order, only two things extra which I mentioned is, one is ideal length of the canal should be reduced, number one. The canal alignment should be such that the crops are grown on the both sides of the irrigation fields are located on both sides of the canal. And third point is crop rotation. These are the three extra points beyond all from the factors affecting duty, you can write it actually. So now I want to concentrate on some of the definitions which are very, very important, because they always seem to be alike. When we really do it, they all appears to be as if they are same, but they are not same. There is a difference between one to the other, that which we will study. What is a crop period? What is a base period? Base period, just now we told, base period means from the first watering to the last watering actually, that is before harvesting, is what we call it as base period. That means before, what you call before sowing the crop, for the preparation of the land also you need to supply water. For that, from that water onwards, even for preparation of the land before sowing the crop, from that time onwards to the last watering is what we call it as base period. That is what we have learned just now. Then what is crop period? Crop period means sowing the crop to the harvesting of the crop. When the plant is raised to the plant is harvested. It is not with reference to water, it is with reference to crop. Crop sowing, crop harvesting. Whatever duration is there between the two, that is what we call it as crop period. Right? Then what is crop ratio? Crop ratio is something related to between seasonal variation. So that means the area irrigated in Rabi to the area irrigated in Kharif is what we call it as crop ratio. Rabi crop area divided by Kharif crop area is what we call it as crop ratio. And what is irrigation? What is irrigation? Actually, we are using the word number of times. Irrigation means artificially supplying of water to the fields for growing the crops. It is an artificial supply of water to the fields to grow the crops. That is what we called as basically irrigation. Then what is the necessity of irrigation? If suppose rainfall is there anyhow, so if rainfall is there, then what is the need of the irrigation? Problem is it is inadequate rainfall. For example, rainfall is not sufficient in particular years. Then what's the alternative? Then similarly, non-uniform distribution. In one area it is very high, in one area it is very low. So non-uniform distribution. And third thing is as the we want to grow number of crops. We don't want to settle with only one crop which can be grown in the rainy season and then stop. We want to grow number of crops, 2 3 we want to grow. Then naturally we need irrigation water. Then commercial crops throughout the year we want to make it, so we need irrigation water. So why irrigation is required? Why artificial supply of water is required? Because it is, number one is rainfall is inadequate, rainfall distribution is not uniform. We want to grow more number of crops. Basically we want to raise the commercial crops. These are the things. And what are the different types of irrigation? The different types of irrigations are called as fundamentally two types. One is flow irrigation, the other one is lift irrigation. Flow irrigation means water flowing on the surface of the earth. Lift irrigation means from the ground, actually from the groundwater, if you are pumping it out, that is what we call it as lift irrigation. Then in the flow irrigation there are different systems, perennial irrigation and then inundation irrigation. And in the flow irrigation can be classified also. One is a direct irrigation. That means for a river, we construct a structure like a diversion structure, like a weir or barrage, and then take a canal from it and supply water to the irrigation fields. Or storage irrigation. So we construct a dam across a river, and then from the dam, we create a reservoir, and from the reservoir we take water into the canals and supply water to the irrigation fields. And combined storage and diversion works. And define what is core depth and core period. Core depth and core period. Core depth means actually, normally if you observe it, in the water requirement in the first watering. First watering means before sowing the crop. Before sowing the crop, when the preparation of the land, when we are making it, it requires more and more water because the soil is dry. So at that time, the more water is required. So how much watering you are making in the first watering is what we call it as core watering. Core watering is the amount of water that you are supplying in the first watering to the field is what we call it as core watering. And whatever depth of water you are supplying during the first watering is called as core depth actually. And what is the period? The portion of the base period. That means during this core watering, that means initially preparation of the land, the first watering, maybe 2-3 days, maybe 5 days, maybe 7 days, maybe 10 days. So that what you are doing it till the soil moisture is attained. So what saturation is being attained, till that time whatever you are supplying. So that is what we call it as core depth. And the period, maybe 1 day, maybe 2 days, maybe 3 days, maybe 5 days. The first watering period, how much it is there, is called as core water period. Then what is outlet factor? The duty at the outlet of is called as outlet factor. And what is paleo? Paleo is the first watering before sowing the crop. Before just you are sowing the crop, when you are making the watering, that watering is what we call it as paleo. Then what is root zone depth? The maximum depth up to which the roots of the plant can be extended, and from there the plant extracts water from the soil is what we call it as root zone depth. And what is the capacity factor? It is nothing but actually whatever is the discharge flowing in the canal divided by the full discharge, full supply of the canal is what we call it as capacity factor. What is cubic day? So that means 1 cubic of water you are supplying, 1 meter cube per second of water you are supplying for 1 day. That is what we call it as cubic day. Distinguish between gross command area, culturable command area. Gross command area means actually the area lying between the drainage boundaries. Suppose this is the drainage boundaries. So and this is the canal system. Right? The area lying between the drainage systems which can be commanded, which can be irrigated by this canal system. This is what gross command area. In this gross command area, there may be some habitable areas. there may be some forest like, there may be some roads. So at all those places, irrigation, that means there will not be any crops grown. So if you remove such type of thing, unculturable area, if you remove from that, then remaining is culturable command area. That means where you can really sow the crop, where the fields are available, because this is something which is, and roads are something, and habitable area means buildings and all are there. So naturally they are all not basically come under the irrigation areas. So that cannot be considered. So what you can consider, culturable area means out of the total area minus which area you cannot cultivate. That is what we call it as basically culturable command area. And once culturable command area you get, in the culturable command area there are again two things: culturable cultivated area, culturable uncultivated area. Because the entire cultivable area may not be cultivated. This year you want to cultivate only some portion of it. So whatever exact area you are irrigating during a particular year out of the total cultivable command area is what we call it as cultivable cultivated area of during that season. Cultivable uncultivated area means one particular season you want to leave it. So then whatever area that you are not growing any crop during a season, that is cultivable uncultivated area. What do you mean by intensity of irrigation? The percentage of cultivable commanded area proposed to be irrigated during either a crop season of a or during a year. Suppose how much cultivable command area you are proposing to be irrigated during a crop season or during a year is what we call it as the basically the grass command area, cultivable command area, cultivable cultivable area, cultivable uncultivable area, and the intensity of irrigation. So percentage of the cultivable command area proposed to be irrigated during either a crop season or a year, that is what we call it as intensity of irrigation. So these are the basic things which all you should know it. And the problems, there are one or two problems are there which we will take these problems also in the next class. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.